All right, let's talk about something that sounds like it was ripped straight from the pages of a classic sci-fi novel. But, it might just be the key to our entire clean energy future. We're talking about powering our planet from space.
I mean, just listen to that. It really does sound like something out of a movie, doesn't it? Gigantic structures just floating in the silent void, soaking up the raw, unfiltered power of the sun. It's an incredible image.
And this is where it gets really interesting. This isn't just a futuristic fantasy anymore. Right now, around the world, different countries and private companies are in a race to turn this wild idea into a real working thing. So you gotta ask, why are we even looking to space for power? I mean, we have solar panels here, right? Well, to really get why this idea is so compelling, we first have to look at the problems we're facing right here on the ground. As amazing as solar and wind power are, they've got some built-in limits. Solar panels obviously don't work when it's dark, and wind turbines don't do much when the air is still. Both are totally at the mercy of clouds and weather. Plus, to power our cities, you need to cover huge areas of land. We need something that's always on. Okay, so let's get into the nitty-gritty. How would this even work? How in the world do you get energy from like 36,000 kilometers up in space all the way down to a light bulb in your house? At its core, the concept is just, well, it's beautiful in its simplicity. You go to the one place where the sun is always shining, you grab all that energy, and you just send it down to where we all live. So here's how it all fits together, step by step. First, you put these enormous solar satellites in a special kind of orbit, geosynchronous, where they're almost always in direct sunlight. Then, on the satellite, that solar energy gets converted into microwaves. Step 3. A big antenna beams those microwaves safely down to Earth. And finally, on the ground, a giant receiver, and this is a great word, it's called a rectenna, catches that beam and turns it right back into electricity that flows into the grid. It's a pretty slick 4-step process. So, again, why go to all this trouble? What's the massive advantage of doing all of this in space instead of just, building more solar farms out in the desert? Well, the answer comes down to one word: consistency. And this number says it all. A satellite way up there in geosynchronous orbit gets hit with sunlight over 99% of the year. Think about that. No clouds, no night, no seasons getting in the way. Just a constant, non-stop river of solar energy. And when you put them side by side, the difference is just staggering. On the ground, power that comes and goes. In space, it's on 24/7. Here on Earth, our atmosphere actually filters out and blocks about 30% of the sun's intensity. In space, you get the raw, unfiltered stuff. This means space solar isn't a variable source. It's what we call true baseload power. That's the steady, reliable kind of energy that can power a whole country. And you could, theoretically, beam it anywhere on the planet. Now, if this idea is so great, you're probably thinking, why don't we have it already? Well, that's a fair question, because the truth is this dream has been on a very, very long journey. People have been thinking about this for decades. Believe it or not, the basic idea was first proposed way back in 1968 by an engineer named Peter Glasser. Then the energy crisis in the 70s got NASA really interested, but the hurdles just seemed too big at the time. While interest in the US kind of faded, Japan's space agency kept the research going. And now, thanks to climate change and some incredible new tech, there's this huge, renewed interest all over the globe. Which leads us to the big, crucial question. If we've known about this for more than 50 years, what was the holdup? What was the one giant obstacle that kept this amazing technology stuck on the drawing board for so long? It all came down to one thing, one number: the absolutely mind-boggling cost of just getting stuff into space. For decades, that one factor made the whole idea completely impossible from a financial standpoint. Yeah, see, these early designs, they weren't for small things. They were for colossal structures weighing tens of thousands of tons. With the old disposable rockets, launching that much stuff into orbit would have cost, well, not billions, but literally trillions of dollars. The price tag alone was enough to make sure the project never left the ground. And this is the moment where everything changes. With the arrival of reusable rockets, the cost to launch a kilogram into orbit has absolutely plummeted. The single biggest wall that held this idea back for half a century is finally starting to crumble. So that leaves us with a pretty incredible question to think about. We've seen the potential here: constant, clean energy from above. We know the old barriers, and we're seeing the new technology that's tearing them down. So what do you think? Is this the decade that humanity finally reaches up and starts grabbing power straight from the sun?